Hello friends, in this video we are going to look at HashSet buckets. So the buckets are actually hashCode based. Java HashSet buckets. In the previous example we looked at the HashSet example. There we looked at the basic functionality of a HashSet. And during that time we doesn't explore much about the bucket. So now it's time to explore how buckets work in HashSet. So in the last video we also talked about bucket, but we doesn't dig deep into it. So we just told that HashSet operates on Java buckets, the hash table under buckets. Now we will explore more about buckets and how it improves the performance. Here we are talking about HashSet buckets. Actually, bucket is for any collection that supports hashing and a hash table. Alright. So now, since in this video series at present we are learning the HashSet, now we will learn about a HashSet bucket. Let us say we have one big basket. We also assume that we have colored disk with numbers in it. If you see here is a green disk with a number 6 in it. Let us say like that there will be various color disks and with numbers in it, and those disks are placed inside this big basket. So now this basket has a colored disks, and all these colored disks are mixed in one big basket. Here, for demonstration purpose, we just created some disk with a color number in it, but you can imagine in each color there will be 1 to 100 disks, or even 1,000 or million. For now you can imagine 1 to 100 disks in each color, and they are all placed in one single basket, and they are shuffled and mixed together. Now if I ask you to check green disk with a number 67 in the basket, and I'm asking you tell me whether that disk number 67 in green color exists in this basket or not, and assume that there are 1 to 100 disks in each color, and there will be some missing disk also. Soon you will be searching the basket with green color disk, and you will be looking for a number 67. When your search process is going on, you will immediately find that it will be tough if all the disks are mixed here in one single basket. So you'll be thinking that categorizing this color in a separate basket, or you will be picking green disk from this basket and you are keeping it somewhere else. Then after that you will be checking for disk number 67, right? So that's what we will do. All right. Now let us say instead of keeping all the colored disks on one single basket, we kept the disk in a separate basket. So there are color baskets. Now the disks are placed in colored buckets, means red disk in red bucket, black disk in black bucket, and so on. Now if somebody asks for green disk 9, or if each bucket has 100 disk in it, and if somebody asks you to get green disk 67, you will definitely searching only the green disk, and you will be, the green bucket. So you will be skipping the yellow, black and red buckets, because you definitely know that the claim here is for green disk and the disk number is 67. So definitely that disk will be there in the green bucket, not in the other three category. So you directly come to this green bucket, then you start searching for the numbers. And you may also think that there are 100 disks. If there is a compartment inside this green bucket, and 1 to 10 is placed in one compartment, and 10 to 20 is placed in some other compartment, then it will be easy to find. Because once you reach the bucket, then you will look at a specific compartment in which the disks are arranged from 50 to 60. So that way you will just check only 10 disks and say disk number 57 or 67, whatever is asked, that is there in that specific compartment. So this is what called bucketing. So first, big basket is divided into different category. Then inside the category we placed the disk. And if here, since it is just 10 disk, it's okay. If it is 100 disk, then we maybe we can even also place some other compartment inside these buckets, and we can categorize that. And inside each compartment we will place a range of disk, 1 to 10 in one compartment, and 10 to 20 in a different compartment, like that. So this will help when you want to pick a specific color disk, and you can pick a disk in a quick way compared to all the disks mixed in a single basket. So if there are 10 colored disks and each has 100, then 1000 disks are placed in one single big basket, and finding a particular colored disk that a bucket is not easy. And your answer of the disk exists in the bucket or it doesn't exist will be tougher one. So you can give the answer always with a doubt, stating that it exists. If you say, then your other brain thinks, did I check it correctly? Alright. Here if you see, we avoided our search in other basket and saved time, other basket or bucket, whatever it is. So that's the purpose of categorizing. So here the same way the hash map works in Java. Here we talked about color buckets. In Java the buckets are actually numbered. So when we talk about number, then there will be a range of number that will go inside there will be elements that is numbered. So the range of numbered elements go in one bucket, and other range of numbered elements will go in some other bucket. So when we say element with a number, that's why we use the hash code. So whatever is the class and whatever is its number, it can be a integer, float, or some other class member, or a string or array, whatever it is. Finally, with the hash code we will be generating a integer number, and we say that when two objects are equal, they both will give same integer number. So that's the purpose of hash code. So you take an object and you generate a integer code out of that object. Since we have an integer code, then we can place that integer code in a particular bucket. So if your object generates some integer code within a range of 1 to 1000, then you can place those. We can actually provide a category based on this 1 to 1000 integer numbers. That means 1 to 100 one basket, and 100 to 200 in some other basket, like that. Then when somebody asks you to compare an object, you will generate a hash code out of that climbing object. Then since the elements are already placed in a basket based on the hash code, you will go to that specific hash code based on the generated hash code. So your contents will work faster. So whatever I summarized now, it may be a little bit confusing at this moment. So we will explore that with Eclipse so that you will get a good picture of what we are talking here. Alright, now let us go to the Eclipse demo. So in our first test run, we are going to add 25 product. After that, we will explore the buckets, and when we are exploring, you can see that there will be no bucket since the products are just 25. First, we will place the required imports. One is the set and another one is the hash set. It is just like our previous example. So we just imported the required packages. Then here we are adding 25 products. If you see here, first we are clearing the product from our hash set. Here is the hash set created, and we are storing that in a products reference. First we are clearing that. After that we are running a loop. Then so the loop will run for 1 to 25. That means we are adding 25 products in the initial stage. So this is our product ID, and we are naming the product with this number itself. This is just a demo. The name is not important. What is important is how it is arranging the product in a bucket, or it distributes the product inside various buckets. Right. So the product ID is important. Why? Because our hash code is going to generate the hash code based on this product ID. All right. Since the loop runs for 25 times, I don't want to keep a breakpoint inside this loop, so I'm just keeping it outside of the loop. Alright, now let us execute this, and if you see already it called our hash code override. So we added this sysout in the previous video, right? Alright. Now the product size is 25, and that will also get printed. So our product size is 25. So before that, what we can do, we will explore how it is arranged. So if I expand this product, you can see there are slats 0 to 25 slats. That means all products are staying in individual slots. Since Java says there is no performance impact, it just keeps all in one single slat, and there is no bucketing here. You can still see that they all are kept inside a single basket or single bucket, because the size is only 25. Right. Now we will increase the size to 1000. Once we increase the size to 1000, we can see the formation of buckets in Eclipse itself. While debugging, you can see those buckets. So here if you see, we just increased the loop size. First we are clearing the product, whatever is added in our code snippet 2, that we are clearing it. After that we are adding 1000 product. Then we are checking the size. After that we are checking the contains method also. This is just for demonstration purpose and how quick it will search. Alright, let us take all this code. and place it here. So we can place it after this code, or we can even completely remove this and we can place. So since I named it as snippet 1, snippet 2, let me keep it here. Actually not required. If you can simply just increase the size and you can check it. Anyhow, here we are clearing it. Let me keep the breakpoint here. So when the breakpoint hits, by that time it may added 1000 product in it. So let me move the breakpoint to the contains method. So if you see here, can clear this, and it says that the size is now 1000. Now here we are searching for the product 231. There are 1000 product now. We are searching for the product 231. So first we constructed the product. Now we are making call to our contains method, and 231 is the product ID and product name is product-231. So if I expand it, now you can see the buckets. If you see here, these are all the bucket. So when we make a call to the contains method, it skips the very first bucket. Why? Because the bucket is for the product that ranges from 0 to 99. If you see here, the hash code comes into picture. So based on our hash code return value, the products are placed inside the separate bucket. Now when we make a call to contains method, it generates the hash code first. So this is the product we are searching, P1. It's a new product in the heap, and there is a product in the hash map also, sorry, hash set also. So the P1 is 231. So what happens, the hash code is generated for product-231, that is the hash code gives 231. So now the 231 will not be here in this bucket, it will not be here in this bucket also, so it will be available in the third bucket. The third bucket is the range of product 200 to 299. So whatever product that generated the hash code integer in between 200 and 299, that will be placed inside this third bucket. So now the hash code generation for this product P1 is 231. That's why we are directly going here to the third bucket. So now we know that the product, if it is there, it will be there in the third bucket. So if it is not in the third bucket, definitely then the product will not be there. So now if we expand here, then we will search for the product here. So it is a 231, right? So if we search at 230, we will, so the index based, right? So 231 and a product 231. So it matches 231, product 231 and a product 231. Since there is a hash code match, now we are 99.999% sure that these two products are equal. So to avoid that error tolerance, now we are making call to the, the Java HashSet is making call to the equals override also. So it makes call to the equals override that present in the product class implementation. So once that method also states that the product is equal, why? Because it's going to compare product ID. So the P1 product ID is 231, and whatever is here in the bucket, that also has a product ID of 231, prod ID 231. The field prod ID is 231. So the equals method returns true. Since that method also returns true, the contains method will state that I found your product. So I found your product in the third bucket at a certain slot. All right. Now if you see here, we are constructing let me clear this. We are constructing one more product, and this product ID is 3661. If you look at our bucket range, it is still 1000 only. So definitely this product doesn't fall under any bucket. So now if you see, it will just generate the hash code. After generating the hash code, it will check the range of buckets. Since it doesn't find any bucket, it immediately returns stating that a product not found. And if you see, there is no call to equals method here. That's all. So collection called our hash code. The hash code for product 361 is a 3661, and since there is no range available here, it immediately returned false. That means the product 3661 is not available here. Alright, now let us go to our final test run. Before that, I will remove this breakpoint and I will clear the output. Now we are going to load 100,000 products. That means almost 1 lakh, exactly 1 lakh product we are going to load into HashSet. So here we saw the buckets, right? Now since the bucket size is increasing, now we can see buckets of bucket. Previously inside the bucket, 100 product is grouped together in a bucket. Now since the product is increasing, the products are already grouped inside a bucket, then the bucket is grouped inside a big bucket. Or you can see it as a compartment, and inside a compartment you will, or a room, inside a room you will place 100 bucket, and in a next room, a numbered room, you can see, we will place some next set of bucket. So the same way here Java arranges the product, and when you visualize it, you will get a more picture. So I will copy this code. Here if you see, we are increasing the product further. So I already cleared a breakpoint. Now I will place a breakpoint here. So when breakpoint hits here, by that time Java already added 1 lakh product inside the HashSet collection. Now we will run it. It may take some while, because since we are outputting something in the console output window, that means through this hash code. Why? Because when we are adding the product, it is making call to our hash code, right? So it may take a while, so just keep wait. Alright, so it's added. Now it hit the breakpoint also. Now we will clear it. So the size is now 1 lakh. Now we are searching a product 12,157, and if you see, if I expand this product, you will see a range of bucket first. So the range is now 1000, so 10,000 elements in one bucket. So first 10,000, 10,000 to 20,000, 20,000 to 30,000, likewise 90,000 to 1 lakh. So there are 10 big baskets. Now what we are searching is 12,157. That means it will not be here, but it falls under this range. Now if I expand here, once again there is a bucket. So that's why we call it as a bucket of bucket, right? So first this is a bucket. Inside this bucket there will be some more bucket. So here what we are searching is 12,157. So 12,157. So definitely it will be available here, because this is the range. If it is available, it will be available here, otherwise it will not be there. So if I expand this, 12,157, right? So 12,000. See, here we are manually picking the product, right? Just by drilling down. You can see how quick I picked it. So when it is given to the computer system, you can imagine how quick it will be based on the bucketing algorithm. So first it needs to generate the hash code. After that, it will search the bucket that is formed based on this hash code. Then once it finds the element, then for double conformance, it will check whether the equals method returns true. So if it doesn't find this in this bucket, then it will directly return I don't find the element. Suppose if for example 152 is missing here and we are asking to find 152, 151, 153 and 2 is missing. So when it search, it will find that there is no object with the hash code 152. So it will say that I don't find the product. But if it finds one, then for double conformance, it will check the equals method also. Now here we find 157. Here is the call to contents method. Definitely it will generate the hash code. Then based on that hash code, so here it is 12,157, right? So based on that, it will drill down. Since I already drilled down, I don't want to do it once again. 12,157. So when it finds the matching node based on this hash code, then it will make a call to the equals method also to make it 100% sure that the objects are equal. Alright, so here you saw how the bucket worked, right? I hope now you will have a good idea of how buckets work in hash table based collection. So HashSet is a hash table based collection. So that's all here in this video. Thank you for watching. If you like the channel, subscribe it. Bye for now.